It's Dr. Bhatt here. Today again we shall discuss something about the contact angle in liquids. Now, before we get into anything, we need to know what is the angle of contact and how it affects the meniscus formation, including the capillary action in liquids. So that's the topic. So, what is contact angle? Firstly, contact angle is the angle subtended by the tangent drawn at the point of contact of a liquid surface with the solid surface hmm, due to adhesive and cohesive forces. When the cohesive forces become lesser than the adhesive forces, or in other words, when the adhesive forces are stronger than the cohesive forces, uh, there is uh, a particular action regarding meniscus formation and the capillary action in liquids. Now let us see what is there for us. Now this diagram is self-explanatory and gives all idea about the dependence of capillary action and the angle of contact and meniscus formation. What is capillary action? We have already learned. And capillary action, I'll just revise. A thin diameter or very small diameter tube when dipped into the liquid causes either the liquid to rise up in the tube from the surface or fall down in the tube from the surface, or in certain cases, rarely of course, it would be flat. Now here is a diagram. Let us study what is there. There is a liquid taken into three different containers, same liquid. Now the liquids are of different nature. It may be chemically different, and depending upon the cohesive forces and the adhesive forces and also the angle of contact, we find that the liquid rises to a certain time, certain height, and forms a meniscus which may be concave or which may be convex, or it may be in certain cases flat also. Now this depends upon the angle of contact, which is denoted by theta. If theta is less than 90, what is the angle of contact? I have already given you an idea. Uh, then what happens that the cohesive forces is lesser than the adhesive forces at the point of contact of the liquid. Now in such cases, if you draw a tangent at the point of contact with the liquid, we find an angle subtended, and this angle is less than 90, means it is an acute angle, and in such case you get a concave meniscus and the liquid rises to a height equal to h from its surface. Why does it happen? It is because of the adhesive forces being greater, uh, adhesive forces being greater than the cohesive forces. Or in other words, you can say the cohesive forces are less than the adhesive forces. Then if it is just 90, the angle of contact is 90, we get a flat surface. The liquid doesn't rise up or fall down from the surface of the liquid. And the angle of contact is 90. Of course, a flat surface with no rise or fall in the capillary tube is a rare case. The example, of course, one example can be quoted, that when we take pure water in pure silver container, we find that the surface is flat. Then a convex meniscus is formed when the contact angle theta is greater than 90. Here in this case, the cohesive force is greater than the adhesive force, and the liquid falls down from its surface to a height h. This is the surface and the height is h. Now here the liquid bulges out forming a convex shape. The very good example is mercury. Mercury, as we know, is used in thermometers and barometers and has got a convex shape at the meniscus. Okay, this is all we have to give you today, and thank you very much. Uh, Thank you. We shall be back again with some more details about capillary action. Thank you.